Geoprocessing Workflows using Python. For this tutorial, I'd like you to follow along. Start by launching ArcPy, and in the Start page, open a new project using the Map template. Call the project Geoprocessing Workflows, and store the project on the computer desktop. You may need to browse to that location and select the folder. I want you to create 3 additional subfolders in this workspace: Original, Working, and Final. The original folder is for any data you want to preserve in its original condition. The working folder is for storing copies of any tables, shapefiles, or other data that you plan to modify. It's always important to separate original copies from working copies to have a backup. The final folder stores any finished products, such as reports or maps. You'll be using these 3 subfolders in conjunction with the project geodatabase. The geodatabase will serve as the default output location to store newly created data. The working folder versus the project file geodatabase. You may be tempted to store your outputs to the working folder. I don't recommend doing that. When you store datasets in a file geodatabase, it changes the file formats. Some of these file formats, such as the geodatabase feature class, work significantly different than the types of files you would store in a folder, such as a shapefile. Deciding not to save your outputs to the geodatabase can produce errors or unexpected results. If you want to save yourself headaches, I recommend sticking with the instructions that I provide. Downloading the data. I've provided some data to use with this tutorial. Check the assignment page in Canvas. There will be a link to take you to a Google Drive page. From Google Drive, click the Download button. After downloading a copy of the 7Z file from your Downloads folder to your original folder, right-click on the 7Z file, choose 7-zip, then Extract Here. Once the data is extracted, you can delete the 7Z file. Back in ArcPy, go to the Catalog pane and expand the folders. Navigate to the original folder and make sure that you see the data there. If necessary, you can refresh the Catalog pane. Adding a notebook to the project. Add a notebook to your project and arrange the tabs as New Vertical Tab Group to see them side by side. Rename the notebook Geoprocessing Workflows. Organize the notebook into sections using headings. Use an H1 style heading and type the name of the activity, Geoprocessing Workflows using Python. In the next cell, use an H2 style heading and type Geospatial Programming 1. On the next line, use an H3 style heading and type in your name and then the date below. Setting up the geoprocessing environments. For your next heading, use an H1 style and type Set Geoprocessing Environments. When you open a new project, ArcGIS Pro automatically creates a workspace folder and a new geodatabase that serves as the default output location. As a result, if you're working within ArcPro, you really don't have to set the geoprocessing environments as you are now. However, it's a good habit to get into at the start of any project. It's important for you to know how to do this for several reasons. First, you may not always want your tool outputs to go to the default geodatabase location. Setting the geoprocessing environments at the start of any project is a way to remind you where your outputs get saved. Thus, it allows you to change them if necessary. Another reason for developing this habit is that you may not always work within ArcPro. If you're working from an external IDE, such as PyCharm, then setting the geoprocessing environments is required for your tools to work properly. Finally, this step includes changing the default override settings for this project. By default, ArcPro won't let you overwrite files. In a programming environment, you need to be able to rerun your scripts for testing and debugging. So it's necessary to overwrite previous outputs. In the next cell, type in arcpy.env.workspace equals R. In Microsoft Windows, navigate to the project geodatabase and copy the path. If you recall, you can do this with a right-click. Paste the path after the letter R. The opening and closing quotation marks are included. After typing in the opening quotation marks, some of you may have discovered a shortcut to this path using the Tab key. However, I would like you to learn the long way in case you are using an external IDE in the future. Once you are sure you will remember how to do it, you can use the shortcut. If you do use the shortcut, the notebook will want to add a trailing backslash that will cause problems. Removing the trailing backslashes is something that you should remember, as this problem will arise in the future. I highly recommend taking notes. This next step is very important. Typically, you can't overwrite existing datasets. You need to change the default settings so that when you rerun a script, it will automatically overwrite any previous files that it created. If you don't do this, the script won't work after the first time you run it. ArcPro won't want to overwrite the previous file. Type in arcpy.env.overwriteOutput equals true. Go ahead and run the cell and make sure there are no errors. Making working copies of the data. In the next cell, add an H1 heading, Make Working Copies. Then add an H2 heading, Feature Class to Shapefile. Part of the workflow I recommend is that you make copies of your original data to have a fresh backup. As I've mentioned earlier, the working folder is for storing copies of any tables, shapefiles, or other data that you plan to modify. In this segment, I will demonstrate two methods from ArcPy's conversion module. The first one is called Feature Class to Shapefile. Take a moment to read the online Esri help documentation for this method. Whenever you use the online Esri help documentation, be sure to read the correct version for ArcPro. At this time, the most current version is ArcGIS Pro 2.9. It does not always make a difference, but the syntax for some methods can change over time. Most pages will have a direct link to get to the different versions. You'll most likely use this method in the future, so I recommend bookmarking this page. This method takes a feature class or shapefile as the input and copies it to a folder as a shapefile. The output parameter is always a folder. The result is a copy of the data with an identical name. I like this method because it's very straightforward. You have one input parameter and one output, so you're less likely to make mistakes. I want to save time, so I'll write a script that will batch copy all of the shapefiles from the original folder to the working folder. I plan to use the list feature classes method to create a list of the shapefiles presently within the original folder. However, the list feature classes method only works on the current workspace. So the first thing I need to do is to temporarily change the workspace from the project geodatabase to the original folder. At the end of the script, I will return the workspace to the project geodatabase. To start, I'll type in arcpy.env.workspace equals open quotes. Then I will hit the tab key and select the original folder. Don't forget to remove the trailing backslash or you will get an error. Now, running the list feature classes method will create a list of shapefiles located in the original folder. I'll assign the list to a variable called fclist. Next, I'll use a for loop to iterate over the list. When I press return, the notebook automatically indents for me. In the next line, I will run the method with the variable feature class as the input. I'll type in a capital F to find the method, feature class to shapefile. And for the first parameter, I'll use the variable called feature class. Then I'll type in the opening quotation mark and press the tab key to select the working folder from the output. Once again, I need to remove the trailing backslash. You might be wondering why I don't just type in the word working instead of pressing the tab key and then deleting the backslash. I can, and it would work just fine. However, I can't tell you how often I've seen students misspell folder names. And don't forget that Python is case sensitive. Pressing the tab key ensures that the spelling and the case are precisely matched. This next part is important, so don't skip it. I will reassign the project geodatabase as the workspace. The geodatabase is the default location of the workspace, and if I don't change it back, the chances are very high that I will make a mistake later. Do this every time to be confident that any output is saved to the correct location in the future. This code belongs outside of the for loop, so hit the backspace key before typing it in. Now I'm ready to run the cell. It may take a little while to run, so leave it alone until you see that the cell has an in number. When I check my working folder in the catalog pane, I see that all of the shapefiles have been copied over. Add an H2 heading, feature class to feature class in the next cell. Take a moment to read through the documentation for this method. It's a quite bit more complicated, and I'm showing it to you because this method allows you to specify the name of the output files, whereas the feature class to shapefile method does not. While this does not normally pose a significant challenge, it gets tricky when writing a script for batch processing. In the next cell, copy the first 3 lines of code. The last line should have the start of your for loop. Press enter and make sure that the next line is indented. Type fc_desc equals arcpy.da.describe open parentheses. Enter the feature class variable as the parameter for the describe method. I'll talk more about the describe method later. For now, just know that this method will allow you to use the base name of each shapefile, that is, the name without the .shp extension. To do this, type name equals fc underscore desc, open bracket, open quotes, and then type base name with a lowercase b for base and an uppercase N for name. Now that I have a variable that will hold the base name as a string, I need to concatenate it with an underscore and the word copy. Now I'm ready to run the feature class to feature class method. For the input feature, I will use the variable feature class. For the output location, I will use the working folder. For the file name, I'll use the copy name variable. Okay, I am ready to run the cell. When I check my results, I see that the shapefiles were copied to the working folder with the correct name. When working in ArcPro, this script also adds the copied files to the contents pane. I will remove the layers with the word copy and replace them with the files with shorter names from the working folder. Exploring spatial datasets. In this segment, I will show you some methods for checking the existence of a dataset and counting the number of features in a dataset. I will also cover the information you can get from the describe method. Add an H1 heading, Exploring Spatial Datasets. There may be times when you are writing a complex program and you need to check for the existence of a dataset before moving forward. It could be part of a branching workflow where your program might do something different based on the results. You can do this with the exists method, which returns a true or a false value. Let's test it out. In the next cell, type arcpy.exists, open parentheses, open quotes, flood zones. Then run the cell. By itself, it's not very impressive, but it could be useful in more complicated scripts. The next method, called getCount, is similar in that it is also simple but practical when used in conjunction with other code. It returns the number of features in a dataset. The number of features corresponds to the number of records or rows in an attribute table. So if I wanted to know how many features or polygons are in the soils feature layer, I would type print arcpy.getCount management soils. So now I know that there are 21,308 polygons in the soils feature layer. This number also references the number of records or rows in the soils feature layer attribute table. I used a print statement this time to visually check the number of records. However, you can easily store the value into a variable for later use. Next, I'll go over the describe method from ArcPy's data access module. There are multiple versions of the describe method, and the most recent comes from the data access module. Though having identical names for methods that do nearly the same thing is confusing, Esri did it this way so as not to break older scripts. The version of the describe method in the data access module is the most current, and it is much more powerful than the older version. Take a moment to look up the documentation for the data access module and read through it. Anytime you want to access or edit a dataset, chances are that you will use one of the classes and methods from the data access module. As I mentioned earlier, be aware that many older functions have the same name. You can differentiate between the two by referencing the data access module with a DA followed by a dot before the method's name. When you're done reading through the documentation, use the link to go to the documentation for the data access describe method and read through it. Pay special attention to the syntax and parameters. The describe function returns a dictionary with multiple key value pairs. The dictionary's keys are dynamic. That means they will change depending on what type of data is described. Some data types will return different properties than others. For example, I'll call the describe method with the soils feature layer as the parameter. I'll leave out the optional parameter for now. As you can see, the dictionary is extensive, and not all of the information is necessarily useful. It makes more sense to specify the information you want using the dictionary key. In the next cell, call the describe method again. This time, I will use the value that I want by adding the dictionary key immediately after the closing parentheses. You need to use a string enclosed in a pair of brackets. In this case, I'll use the data type string. Notice that the T is capitalized. Remember that Python is case sensitive, and many of the keys include capital letters in the second word. You can find out more in the online help documentation on the page for the describe object properties. Now I'll check the spatial reference for the soils feature layer. This time I get more information in a table, which looks nicer and is easy to understand. So you can see that some of the describe object properties return more than strings. Checking the spatial reference of your feature layers is something you should do every time you conduct an analysis. Two or more feature layers using different spatial reference systems have a high probability of introducing errors into your analysis. Next, I'll write a script that will check the spatial reference of each feature layer in the contents pane. The script will also return specific portions of the spatial reference properties rather than the whole table. First, I'll create a list of all the features in the contents pane. Next, I'll create a for loop to iterate over the list. I'll call the describe method for each item in the list. Then I'll assign specific describe object properties to a series of variables. I'll add a period and the property I want right after the closing bracket for the spatial reference properties. In this instance, I want the spatial reference properties to tell me if the spatial reference system is geographic or projected. On the next line, I'll get the name of the spatial reference system. Finally, I will print the results to the screen using an F string to include all my variables. The result is the layer's name, followed by the type and name of the spatial reference system. Geoprocessing Workflows. In this segment, I'll run you through some geoprocessing tools. This activity will help you practice running geoprocessing tools using a Python script rather than the graphic user interface. On the next line, add an H1 heading, Geoprocessing Workflows. There are several things to remember when you're first starting. Always have a browser open and ready to find the Python syntax for geoprocessing tools using the Esri online help documentation. It would be good to bookmark the page for the tools you use frequently. If you think you know the parameters of a method, but are not sure, remember that you can call the usage function for quick reference. However, this method requires that you at least know the Python name for the tool. Locate the Esri online help documentation for the clip tool. You can use the keywords ArcGIS Pro clip analysis. Take the time to read through the documentation to understand how the tool works. You will likely be using this tool often, so consider bookmarking this page for future reference. According to the documentation, the clip method has 3 required parameters: the feature to be clipped, the features used for the clip's shape, and the output dataset. There is an optional parameter, but it can cause more trouble than it's worth, and we'll not be using that one. Skill drill. For this next segment, I would like you to pause the video. Use the syntax provided in the documentation to run the clip tool. The feature to be clipped is the soil feature layer. The clip feature will be the basin. Call the output soils_clip. When you're ready, run the cell. Pause the video while you work. I'll walk through the next steps afterwards so you can check your results. If you encounter any errors, do your best to troubleshoot the cause before checking the answer. I know it's tempting to skip this step, but learning code takes practice, and learning how to troubleshoot is essential. Okay, so I'll start by typing in the correct syntax for the clip function. ArcPy.analysis.clip. Followed by open parentheses. For the input feature layer, I'll add the soils feature layer as a string, ensuring that the spelling and case match what's in the contents pane. The basin is my clip feature, so I'll type that in next. Last, I will name my output soils clip with an underscore between the two words. I'll look over to check for any errors and run the cell. I received no error message, so it worked as far as I can tell. Hopefully you got your code to work as well. Remove the original soils layer from the contents pane to see the results more clearly. As you can see, the clipped soils layer is now in the same shape as the basin. On the next line, add an H2 heading, clip multiple feature classes with batch processing. Personally, I think it was easier and faster than using the graphic user interface to run the tool. I didn't have to search for any buttons or tools once I knew the syntax. As you become familiar with the tools you frequently use, it should be easier for you as well. There's an even faster way to work when you have multiple feature layers that you want to clip. You can write a script that loops through a list of feature layers, calling the clip function for each one. Skill drill. See if you can figure out how to write a script that iterates through a list of the remaining feature layers and clips them to the shape of the basin. The output should have the same name as the layer, followed by an underscore and the word clip. Pause the video while you work. You can check your answers when you're ready. I'll start by creating a list of feature layers in the contents pane that I want to clip. The best method for iterating over a list will be the for loop. So I'll type for layer in clip list colon. Jupyter Notebook automatically indents the next line for me. On that line, I will run the clip method. I'll use the variable layer from the for loop as the input. Because it is a variable, I don't need to include any quotation marks. Like before, the clip feature is going to be the basin. I will use the variable layer for the output and concatenate it with a string that includes an underscore and the word clip. I'll take a moment to check for errors. Then I will run the cell. Didn't get any errors, and looking at my contents pane, it seems to have worked. I'll remove the original layers from the table of contents. In the next cell, I'll add an H2 heading, identify flood zones within the basin using the select method. So by now you should be familiar with running tools using Python and the modules available in the ArcPy package. You also know where to look to find the syntax for a specific method. I'll show you how to write a script that includes an attribute query in this next segment. The goal is to select the polygons from the clipped flood zones where the SFHA attribute equals in. I'll use that selection to create a new feature class saved to the project geodatabase. In ArcPro, select the clipped flood zones in the Contents pane. Make sure the Map tab is active and then navigate to the Data tab and open the Attribute table. Locate the SFHA field. This field represents which polygons are inside the flood zone and outside the flood zone. There are only two values, in and out, just like the restaurant. You'll need to look up the syntax for the Select Analysis tool in the ArcPro help documentation. This tool has two required parameters and one optional parameter called Where clause. You are going to need to use all three. The Where clause parameter creates a selection using structured query language, or SQL. There are some examples in the documentation. In the next cell, I will call the select method. For the input, I'll use the clipped flood zones layer. I'll call the output flooding. The where clause needs to be entered as a string. Open quotes, SFHA equals. Then I'll enclose the attribute value in a pair of single quotes. It's important to remember that SQL is not Python, and it has different rules. In SQL, the syntax for any attributes requires a pair of single quotes, unless they consist of numbers. I'll go ahead and remove the clipped flood zones from the map to see the results. As you can see, a line of script was all that is necessary to select features by their attributes and then save that selection as a feature class in the default geodatabase. In the next cell, add an H2 heading, working with optional parameters. In this segment, I want to create a buffer around the flood zones of 100 meters using an optional parameter, the dissolve option. Let's take a look at the documentation for the buffer method. The first parameter is the input feature layer, followed by the output feature class. Next is the buffer distance, or a field from the attribute table of the input feature layer. I want to skip over the next two optional parameters to get to the dissolve option. The default value for the dissolve option is none. The other two options are all and list, depending on how you want the buffers to overlap. You can dissolve all of the buffers into a single feature, removing overlapping polygons. You can also dissolve features based on an attribute field. Polygons with the same attribute will be dissolved together, and they'll overlap polygons with different attributes. I don't want any overlap between the polygons, so I plan to set this value to all. Typically, the arguments for parameters must be entered in a specific order as defined by the syntax. When you want to skip an optional parameter, you can do so by entering a set of empty quotes, like so. Another way to get to the dissolve option parameter is to reference the parameter's name. I'll show you how by creating another buffer of 50 meters. I don't need to enter any empty quotes if I reference the dissolve option directly. And that concludes this tutorial. Please take a moment to save your notebook to your final folder as an HTML file, and make a backup of your project workspace to Google Drive. Thanks for watching. Don't forget to subscribe to this channel for more videos and tutorials related to geospatial science.